Hello, Year 10. Today we are going to be using quadratic equations to help us solve problems. But before we do the word problems, let's come back here and practice solving like we did last lesson. So the first question is x squared plus 2x minus 15 equals 0. To solve this, we first of all need to factorize it. It's a monic trinomial, so it's going to factorize into two brackets equal to 0. We need to find two numbers that multiply to give the negative 15 and add to give the 2. The numbers that work would be a positive 5 and a negative 3. Now, once our trinomial is factorized, we use null factor to get the solutions. So showing the working out for this first one, that means that either the first bracket, which is x plus 5, is equal to 0, or the second bracket, which is x minus 3, would be equal to 0. To solve each of those, from the first one we get x equals negative 5 for our first solution. And from the second one, we will get x is equal to a positive 3. Okay, on to the second question. We have 2x squared minus 20x minus 22. Now it looks like it's non-monic because we have this 2 in front of the x squared, but each of the terms can be divided by 2, so I can take that out as a common factor, giving x squared minus 10x minus 11 in brackets equal to 0. Then it's another monic trinomial, which means I'm looking for two numbers that times to give negative 11 and add to give negative 10. So that would be a negative 11 and a positive 1. To get the solutions from this, the 2 will not give me any solutions, but from the first bracket, I will get x is equal to positive 11. And from the second bracket, I will get x is equal to negative 1. Question 3 is an equation that has fractions in it. So first of all, I will need to rearrange that to get it into the right form. The first thing I'll do is times the 2x up to the right-hand side. That is 7x plus 10 equals 6x squared. Then putting the trinomial in order, I need the 6x squared first, and I'll move the 7x and the 10 across the other side to get negative 7x minus 10 equals 0. Now this is a non-monic trinomial, so I need to multiply the 6 with the negative 10, and I'm looking for two numbers that will multiply to give negative 60, and they're going to add to give the negative 7 that's in the middle there. So the two numbers that work are going to be minus 12x and plus 5x minus 10. So I'm using the splitting the middle term technique so that I can factorize in pairs. From the first two terms, I'm going to factorize 6 and x out the front, which leaves x minus 2 inside. From the third and fourth term, I can factorize out a 5, which will leave x minus 2 as well. Then the x minus 2 is a factor, and the 6x and the plus 5 will be what remains and goes into a second bracket, equal to 0. So now to use null factor, I get x equals 2 from the first bracket. The second bracket is a little bit messier because it has two numbers, so you may want to go back to using a little equation to solve it, which would be 6x plus 5 equals 0. Minusing the 5, you get 6x equals negative 5, and then dividing by 6, we get our answer, which is x equals minus 5 over 6. And that's it. Okay, so on to our word problems. We're going to be having some problems, a problem that is, as I said, a word problem, and we will need to change it into an equation that we can solve using our quadratics and equations skills. So let's read through the steps that are in this box here. It says, when solving worded problems involving quadratic equations, follow these steps. First of all, define the terms if required. So in some questions, you're not given a pronumeral to use, so you may need to define that from the start. Then convert the sentences or parts of sentences into algebraic terms. Look for the key words such as equal, subtract from, multiply by, so on to help you do that. Write your equation in the form ax squared plus bx plus c equals 0. So that's putting it into our trinomial form in the right order so that it's ready to factorise. Step 5, factorise the left-hand side and then use null factor to solve. Because this is practical problems that we're solving, not all solutions we get from our quadratic equation will be valid, so we need to look back at our original question and decide if the solutions are realistic or not. And then, finally, because it was a word problem, we want to give our answer in a short sentence. Okay, so let's have a look at our first problem. Number 1. The distance travelled by an accelerating car is given by the formula d equals 3t plus t squared. So this is good because I'm already given the equation that I'm going to use and the pronumerals as well, so I don't need to define those. It says where t is time in seconds and d is the distance in metres. If the distance travelled was 130, so this is going to be d for distance, for how long was it travelling? When it asks for how long, it means I'm wanting to find the time, which is the little letter t. Okay, so let's sub the d equals 130 into the formula that I've highlighted there in yellow. The d is replaced with the 130 equals 3t plus t squared. Now I want to put it in the right order. So let's put the t squared first, plus 3t, and then I'm going to subtract the 130 across so that it's equal to 0. Now I can factorise this because it's a monic trinomial. So I'm looking for two numbers that times to give negative 130 and add to give 3. The numbers that we need are positive 13 and negative 10. When I use null factor, I get t is equal to negative 13 from the first bracket, or t is equal to a positive 10 from the second bracket. But let's see if both of these solutions are valid. Remember that the time is talking about how long we have been travelling in this car. Okay, so I can't travel a negative amount of time. So this solution is invalid, and I'll write a little note here saying can't have negative time. Okay, so my solution is that t is equal to 10. I'm going to write that in a short sentence. I'll say, therefore, the car was travelling for 10 seconds. Okay, on to question 2. The area of a rectangle is fixed at 54 metres squared. Okay, we're talking about a shape, so it's always a good idea to have a diagram. Here is my rectangle. The area is 54 metres squared. Then it says its length is 3 metres more than its breadth. So I'm going to make this side x, and then the other side needs to be 3 longer, so it will be x plus 3. Okay, then we are talking about the area of this rectangle. The formula for area of a rectangle is A equals BH. And I'm going to sub in the information that I have. The area is 54. The base and the height are the x times the x plus 3. Expanding that out, I get x squared plus 3x, and then I need to put it in the right order, starting with the x squared plus 3x minus the 54 across from the other side so that it's equal to 0. Factorising. I'm looking for two numbers That will times to give the negative 54 and add to give the 3. It's 9 and negative 6. Using null factor, I get x equals negative 9 from the first bracket, or x equals 6 from the second bracket. But are both of those solutions valid? X represents the side length of the rectangle. The negative 9, you can't have a negative side length, so it is not valid. So again, I'm going to write a little note. Can't have negative side length. And so I need to write my solution down as a little sentence. But looking back at the question, it says find the dimensions of the rectangle, which means I need the length and the breadth. So let's say, therefore, the rectangle has dimensions 6, and the units in the question were meters. So it's 6 meters by the other, if x is this shorter side length, x plus 3, which would be 6 plus 3, is 9 meters for the other one. Final question, number 3. Use Pythagoras' theorem to solve for x. So we already know that x is our pronumeral, and Pythagoras' theorem is c squared equals a squared plus b squared. There are other rearrangements of that, but this would be the easiest form to use. C is the hypotenuse, which in this case is going to be x. X squared equals a and b are the two shorter sides. So a is going to be x minus 1, which I need to square, and b is going to be the 5 squared. I have the equation now, I just need to expand it so that I can solve it. Let's leave the x squared. Expanding the perfect square using the short method, we multiply x times x to get x squared. Then we multiply the x by minus 1, which is minus 1x, but then we double that to get minus 2x. Then we times the minus 1 times minus 1 to get a positive 1 on the end. 5 squared is equal to 25. Now, the x squareds, if I were to move the x squared on the left over to the right, I would have x squared minus x squared, and they would cancel out. So 0 is all that remains on the left-hand side. I have minus 2x, and 1 plus 25 makes 26. Because the x squareds are gone, this is no longer a quadratic, and I can just solve this using normal linear equations methods, which is to get the x by itself. So I'm going to move the negative 2x over to the other side to make it positive. 2x equals 26. Then divide by 2, which means x will equal 13. That's all I was asked to find. It said, use Pythagoras' theorem to solve for x, and I have done that, so that's finished. Okay, it's time for you to do exercise 8G.